Lesson 3, its title volumes. Okay. Firstly, we will define the solids. Solids, its definition: any object that occupies a room in the space is called a solid. Again, solids, its definition: any object that occupies a room in the space is called a solid. Okay. Suppose our class, suppose any object occupies a room. Okay. Suppose a carton box. Okay, I have two types or two kinds of solids. The first kind called the geometrical solid. Okay, such as cuboid. First shape called cuboid, as we know that in grade 5 and in grade 4 we know that figure or that shape called a cuboid. Second figure: all sides equal and all faces are equal in area and all faces are congruent. This is called a cube. Okay. The third figure called a sphere. Okay. Firstly, cuboid, cube, and sphere. These are called a geometrical solid. And another shape: another shapes such as cone and cylinder, right circular cylinder, is called a geometrical solid. Okay, because it occupies a space. Lastly, pyramid. Okay, the second type or the second kind called a solid which has no definite a geometrical shape. Okay, non-geometrical shapes. Okay, such as car and stone. Okay, piece of stone, laptop. Okay, these shapes non-geometrical shapes. Okay, non-geometrical solid. Okay, because they are irregular solids. Okay, camera, solid and dull. Lastly, calculator. These shapes called non-defined geometrical shapes or non-defined geometrical solids. Okay. Again, I have two kinds of solids. The first kind called geometrical solid and non-geometrical or undefined geometrical solid. Firstly, I know that its examples: cuboid, cube, and sphere, and cone, and cylinder, and pyramid. Last, number 2, I have a solid which has no definite geometrical shapes such as car, piece of stone, laptop, camera, doll, and calculator. Okay. Firstly, we will know the cuboid. The cuboid. Now we will define the cuboid, its edges and its faces, okay, and its vertices. Firstly, the cuboid has 8 vertices, okay, and has 12 edges, okay, and has 6 faces. This information I have studied in grade 4 or grade 5, okay, but in this year we will know its volume. Okay, in the second lesson, okay, we will talk about its volume. Firstly, the cuboid has 6 faces. Each one is a rectangle. Okay, the face of the cuboid in the shape of rectangle. Okay, again, the cuboid has 6 faces, but each one is a rectangle. As we know that each two opposite faces are congruent. Okay, because if I put each one on the other, they will be identical. Okay, each two opposite faces are congruent and parallel. Number 3, each two adjacent faces intersect at a line segment which is called an edge, okay? An edge, okay? Again, I have two faces. Any two faces in the cuboid intersect at a line segment which is called an edge, okay? The cuboid has 12 edges, 6 faces, 8 vertices, and 3 dimensions. In the cuboid, I call the 3 dimensions length, width, and height. Length not equal, width not equal, height, okay? Again, the cuboid, as we know that, the cuboid has 8 vertices, has 12 edges, has 6 faces. But 6 faces, the 6 faces, each one in the shape of rectangle, and each two adjacent shapes or faces, intersect at a line segment, this line segment called the edge, and each two opposite faces are congruent and parallel. Again, it has 6 faces, each one is a rectangle, each two opposite faces are congruent and parallel. Each two adjacent faces intersect at a line segment which is called an edge. It has 12 edges, 6 faces, 8 vertices, and 3 dimensions, length, width, and height. The cube. Secondly, we will talk about the cube. The cube has 8 vertices and 12 edges and 6 faces. But each one of these faces, each one are parallel to its opposite face, okay? And each one are congruent to the other. Again, all faces of the cube are congruent. Each two opposite faces are parallel, okay? Each two faces intersect at a line segment called edge. All edges of this cube are equal in length. Again, the cube has 6 faces, each face in the shape of a square. All faces are congruent, each two opposite faces are parallel, each two adjacent faces intersect at a line segment called edge. The dimensions, 3 dimension length, width, height, but this cube each face in the shape of square. So the side or the edge of this cube called edge length or the side. The 3 dimensions are equal in length. Length equal width equal height in this cube. So we can call the 3 dimensions as a side length or edge length. Again, the cube has 6 faces, each one is a square. All faces are congruent and equal in area, okay? Because the 6 faces are congruent, this means that all sides are equal, this means that all area of these faces are equal in area, okay? Each two opposite faces are parallel. It has 8 vertices and 12 edges. All the edges are equal in length. It has 3 equal dimensions, length, equal width, equal height. This means that we can call the 3 dimensions edge length. So if we talked about its volume, we can write the volume edge length times edge length times edge length, okay? Edge length times itself, okay? But in the cuboid has 3 dimensions not equal in length. This means that length not equal width, not equal height. So the volume of this cuboid equal length times width times height. Again, the cuboid has 6 faces, but each one is a rectangle. In the cube, it has 6 faces, but each one is a square, okay? Each two opposite faces in the cuboid are congruent and parallel, but all faces in the cube are congruent and each two opposite faces are parallel, okay? Each two adjacent faces intersect at a line segment in the cuboid called the edge. Also in the cube, each two adjacent faces are intersected at a line segment called edges. The 12 edge lengths in the cube are equal in length, But in the cuboid, the 12 edge length not equal in length because the cuboid has 3-dimension length width height not equal, okay? It has 3 equal dimension length equal width equal height, okay? Now we will define the volume. What do you mean of volume? What's the meaning of volume? Volume of a solid, if I required from you to get the volume of cube or cuboid, firstly we will know the volume. What's the meaning of volume? Volume of a solid is the number of units which that solid consists of. Okay, again, the volume of solid is the number of units which that solid consists of. If I know the number of units which the solid consists, this means that I know the volume of this solid. Okay, the cube centimeter, now we will talk about its units. The units of volume, cubic centimeter, okay? Centimeter cube, it is the unit of the solid, and meter cube and millimeter cube, okay? We will define cubic centimeter. This means that it is the volume of a cube of edge length that equal 1 centimeter. This unit is used to measure the volume of a carton of milk or a box of soup and so on. Again, cubic centimeter is the volume of a cube of edge length equal 1 centimeter. But the cubic meter is the volume of a cube of edge length that equal 1 meter, not 1 centimeter. Okay, the same definition, but the edge length in the cubic centimeter equal 1 centimeter, but in the cubic meter the edge length equal 1 meter. Okay, again, the cubic centimeter, it is the volume of cube of edge length that equal 1 centimeter. Suppose the carton of milk, box of soup, and so on. Okay. Converting units. How can I convert from meter cube to centimeter cube to millimeter cube? Okay. I have 4 units. Start from meter cube to decimeter cube to centimeter cube to millimeter cube. As we know that usually we know meter, 1 meter, not 1 meter cube. 1 meter equal 10 decimeter. 1 decimeter equal 10 centimeter. 1 centimeter equal 10 millimeter. But 1 meter cube equal 10 times 10 times 10. 3 on meter, this means that 3 tenths. Okay, 10 times 10 times 10, this means that 1 meter cube equals 1000 decimeter cube, and also decimeter cube equal 1000 centimeter cube. And I know that centimeter, 1 centimeter, not cube, equal 10 millimeter. So centimeter cube equal 1000 millimeter cube. So from meter cube to centimeter cube equal 1 million. Okay, again, meter cube to centimeter cube equal 1 million. So the converting units, 1 meter cube equal 1000 decimeter cube, but 1 decimeter cube equal 1000 centimeter cube. 1 meter cube equal 1 million centimeter cube. 1 centimeter cube, I know that equal 1000 millimeter cube. Okay. Example number 1. Find the volume of the following solids. As we know that the definition of the volume, if I want to know the volume of any solid, I must count the number of units which consist of this solid. Okay, again, if I want to know the volume of any solid, I must count the units which this solid consists of. So I will count this figure. I have a solid consists of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. Okay, 9 units. So the volume of this figure, 9 units. Okay. The second figure, letter B. I have a solid consists of some units. I must count them. If I count them, I will find them equals 12 units. As he told me that one unit cube equals centimeter cube. So the first figure or the first solid, its volume equal 9 centimeter cube or 9 units cube. Letter B, 12 centimeter cube or 12 unit cube. Okay. Example number 2. Complete the following: 5 meter cube, converting it into a decimeter cube. Firstly, I convert from the greatest to the smallest. So I will multiply, as we know that in grade 5 and grade 4. From when I convert from the greatest unit to the smallest unit, I multiply. Okay. I will multiply 5 by 1 meter cube equal what? Decimeter cube equal 1000. So I will multiply 5 by 1000 equal 5000 decimeter cube. Letter B, 0.8 centimeter cube equal what? Millimeter cube. Firstly, I must know from what to what I convert. I convert from greatest unit to the smallest unit. So 1 centimeter cube equal 1000 millimeter cube. So I will multiply 0.8 timing 1000. It will give me 800 millimeter cube. Okay. Letter C, 15,000 centimeter cube, converting it into a decimeter cube. Firstly, I must know from what to what I convert. I convert from centimeter cube to decimeter cube, from the smallest to greatest. So I must divide. Okay, I will divide 15,000 by what? I know that 1 decimeter cube equal 1000 centimeter cube. So I will divide 15,000 by 1000. It will give me 15 decimeter cube. Letter D, 56,000 millimeter cube into centimeter cube. Okay, from millimeter cube to centimeter cube, converting from the smallest unit to the greatest unit. So I will divide. I will divide by what? As we know that centimeter cube equal 1000 millimeter cube. So we will divide 65,000 by 1000. It will give me 65 centimeter cube. Okay. Letter E, 45 million centimeter cube, converting it into a meter cube. Firstly, I convert from centimeter cube to meter, converting into a meter cube. This means that from the smallest unit to the greatest unit. So I will divide. But I will divide this number 45 million by what? I know that 1 meter cube equals 1000 decimeter cube, and 1 decimeter cube equal 1000 centimeter cube. So from when I convert from meter cube to directly to centimeter cube, I will divide by 1 million. Okay, as we know that 1 meter cube equal 1 million centimeter cube. So 45 million divided by 1 million, it will give me 45 meter cube. Lastly, 2.5 meter cube equal what? Decimeter cube. Converting from meter cube into decimeter cube, this means that converting from the greatest unit into a smallest unit. So I will multiply this amount 2.5 by what? Meter cube. 1 meter cube equal 1000 decimeter cube. So I will multiply 2.5 by 1000. It will give me 2500 because I move this point into the right direction 3 points. Okay, so it will be 2500 decimeter cube. Thanks for everybody. Thank you very much.